there is no motion. Let's see if an object changes its position with respect to time. We call it motion. Beautiful. We call it motion. If it does not change its position, we say that there is no motion. Now, motion is a relative term. Relative means maybe it's it depends on the person who is observing, his location, where he is located. So, depending on the person, we can describe a motion. So, motion is a relative term. It's not absolute. If someone say, suppose someone says that motion is absolute. Like if someone says that an object is moving, maybe the object may be moving with respect to someone and may not be moving with respect to someone else. So hence we say that motion is a relative term. It's not absolute. You say that it's moving. It's not necessary that an object will be motion if anyone
Yes.
says. Okay. So it is a relative term. And to describe motion, we take the help of the coordinate system. First of all, we'll talk of the position. So here I will talk of their position, how we can find out the position of an object. So the position of an object can be represented with a vector quantity which we call as a position vector. So if we talk of position vector in two dimensions, so here we can talk of position vector in two dimensions. So let us say, so we have a two-dimensional plane. In this two-dimensional plane, wherever the object is, suppose the object is somewhere at any point in this plane. So the position of the object, suppose the object is at this point, suppose the object is over here. So wherever the object goes, its position will be represented with a position vector. Now the position vector is the position vector. Let's say this be x, here y. So the position vector of the object can be represented as a vector starting from origin and pointing to the object. Suppose this is the first position. Let me call this as the position first P1. So the position vector, I will call the vector OP1 as the first position vector. Then from here, if the object moves to position P2, so its position will be represented by the new position vector OP2 will represent the new position vector. So this is a new position vector OP2. Right. So in this way, wherever the position can be, it can be represented by a position vector. And the position vector is represented or taken as a vector. So here, the position vectors OP1 and OP2. Now, so in this case, if the object moves from the position P1 to P2, I can say that the object has made some displacement, and the displacement of the object it will be taken from the position P1 to the position P2. So this I can represent P1, P2. So this P1, P2 would be the displacement. It would be represented by this arrow. So P1, P2 is the displacement. P1, P2 is the displacement, and OP1, we'll call OP1. See, whatever we write with these two symbols, the first symbol represents the starting point, the second symbol represents the ending point, and the arrow on top of it represents that it is a vector quantity.
It shows
So,
direct.
yes, the arrow represents that it is a vector quantity. So OP1 is the position vector when it was at P1. OP2 is the position vector when it was at P2. So I can say OP1 in position. This is a vector which represents my initial position. OP2 will be a vector representing the final position. So we call this as final position. We call this as the final position. Okay. Now, as we know that the displacement is given as the change of position. So the displacement is given as the change of position. Right? Uh, okay, so the displacement is taken as the change of position. We write here displacement as change of position. So we'll be writing the displacement vector. Now it's in the form of vector. Vectors are the quantities which have magnitude as well as direction. So the displacement vector will be written as final position minus the initial position. It's final position minus initial position. So we'll write the same thing here in the terms of vectors. So the displacement vector P1, P2, this is the displacement vector, and the displacement vector P1, P2 should be equal to the change of position, where we have the final position OP2 minus OP1. So see, this is another way of finding out the displacement in terms of the vector quantities. Okay. So we'll continue a little bit more about the vectors. What are vectors and how do we study about the vectors? Okay. So vectors, before going further detail into the displacement and everything, we'll discuss here something more about the vectors. So vectors, these are quantities which have magnitude as well as direction. So the quantities which have magnitude as well as direction, they are called as vector quantities. So now they are represented with an arrow. So how they are represented, the vectors, this is their geometrical representation. Geometrically, they are represented by an arrow where the tail of the arrow represents starting point. tail of arrow represent starting point and head represents the ending point. So the tail represents the starting point and head represents the ending point over here. Now also the length of the arrow, it represents the magnitude of the vector, and the direction of the arrow represents its direction. So if you have any vector, if I make a vector something like this, let's say I make a vector AB. So the vectors, they can be represented in two ways. Either you mark the starting point and the ending point. Here you have the starting point A and the ending point B. So you can write it as AB and an arrow on top of it. This we read as vector AB. So we call this as vector AB. This is how we read it. Or the vector can also be represented by a single letter. So a single letter can also represent a vector. So suppose I can name this vector with the name, let's say P, and I will represent this vector with vector P in this way. So vectors can either be represented with a single letter, or they can be represented with the two letters, two letter combinations. So here the length of the arrow represents its magnitude, and the direction of it represents the direction of the vector. So for example, if you have two vectors like this, so if suppose I have two vectors, let's say one of the vector be A, let this be the vector A, and let this be vector B. So what I observe here, that vector B is greater than vector A. I can compare here that magnitude of vector B is greater than magnitude of vector A. So this is how we write the magnitude. We can write these vertical lines which will indicate the magnitude of the vector. So in this way, the magnitude of the vector B, and this one is the magnitude of vector A. Right? So these two vertical lines, they mean just the magnitude. That means only the uh, magnitude, not its direction. When we are dealing with vector, if we talk just of its magnitude, then we use these lines. Okay, so this becomes a scalar. If you say, so talk about the direction. So I can say that the direction of both the vectors, they are opposite to each other. Or if the vectors are aligned in a plane, making some angle with them, so I can tell like this. Suppose they are like this, so I will tell that vector A and B, they are aligned with each other, making a certain angle theta. So let's say they are making an angle theta with each other. So I'll say that vector A and B, they are acting at a point O with certain angle theta in between them. The vectors can be moved parallel to each other, parallel to themselves. So for example, if I consider vector A over here, I can even make this vector A move parallel to this and mark it anywhere. Okay. So understood a little bit things about vectors, how we can represent vectors. Okay. So see in the previous one, here if I want to find out the magnitude of the displacement, so the magnitude of displacement would be given by this length of the line P1, P2. The length of the line P1, P2 would give me the magnitude of displacement. And the direction of displacement would be given, the direction of the displacement would be given from the direction with the x-axis or y-axis. You can give the direction of this displacement with the x-axis. Okay. So you can here if you want to place the direction, so you can say that the displacement is making certain angle theta with the x-axis. So in this way, I will specify the displacement. It's not necessary to every time say north, south, east, west. So it's not every time understood as north, south, east, west. We can mark them with the help of coordinates and provide their orientation with the help of angle. So have you understood that how we show the direction and display direction and magnitude of the vector quantities?
Yes, sir.
Okay. So here, if in any plane you are asked about the vector displacement, you can find out its direction, and so you can also find out the direction and its magnitude. So let's consider a small question over here. Okay. So find the displacement here. Of a carom token which moves from 5 to 4, comma 2.
Sir,
So
instead
you
of
have
comma, you're putting a dot, sir.
no, it's comma.
Oh, okay, okay. Yeah, yes, sir.
Okay. So in this way, we have to find out the displacement. So the displacement means we have to find magnitude as well as direction. So if I represent it using the coordinates, so let's make it simple with coordinates. Okay. So here we have taken coordinates and we will represent this with the help of them. So sorry. So this is our y-axis. Here we take the x-axis and let's take the starting point. So if you mark here 0 and 1, 2, 3, 4, 5 on the x-axis, 6. Here we take 1, 2, 3, 4, 5. Now the object moves from 0, 5 to 2. So 0, 5 means the object is initially located at this point. This is your 0, 5 position. And from here it moves to the position 4, 2. So you'll find the position 4, 2, that's this point. Okay. So you have the displacement P1, P2. These are the positions. Then the displacement or the magnitude of the displacement would be given by the length of this line P1, P2. Okay. So how will you find out the displacement? What will be the value of displacement here? Can anyone tell me the magnitude of displacement?
1 minute, sir.
Just one? Just one?
Yeah, yes, sir. Yes.
Okay. Did you attempt the test for physics?
So, so there's no test, I think.
Yeah, there was a test. You should
So
have
that
attempted.
so it's not showing in this
No, it
Pfizer.
was. It is there with in the assessment section. There.
Sir, I got 5 units.
Okay, you got 5 units. So you find the displacement, and the displacement would be given as the distance between these 2 points. So the distance between the 2 points can be given by the distance formula. So this would be equal to under root of 4 minus 0 whole square plus
2 minus 5 whole
2
square.
minus 5 whole square. So this equals
16
16
plus 9.
plus 9, which is under root of 25, and hence the displacement is 5 units.
Yes,
So the
sir.
displacement is 5 units, and now we want to find out its direction. Okay. So see how we will find out the direction. The direction of this vector is given with the positive direction of the x-axis. So here we have the positive direction of the x-axis, and this is the negative direction of x-axis. If you find out this angle, so this angle would be the angle that would represent the direction of the displacement. So to find out this angle, uh, see the displacement is from P1 to P2 like this. So actually the direction comes over here from this direction like this. It is this direction. So this will be the direction equal to the theta over here, not this one. Now you find out this value of theta. So we can find this value of theta by constructing or assuming a right angle triangle over here, where we have this theta will be vertically opposite to this angle theta, and hence the angle can be given as perpendicular by hypotenuse. Since the perpendicular is 3 and base is 4. So you will get here tan theta equal to perpendicular over base, and hence it is 3 over 4.
Yes, sir.
So tan theta is 3 over 4, and hence we can write theta as tan inverse of 3 by 4. Right? But see, the angle over here has to be it has to be a negative angle. Regarding the angle measurement, all the angle which is measured in the anti-clockwise direction, the measurement of the angle, if the angles are measured, it's something like this. So the angle is measured like this. Suppose we take these coordinates and you take a vector, rotating vector here. So we take here a rotating vector. The rotating vector, if it rotates like this in the anti-clockwise direction, so in this way the angle would be taken as positive. However, if the same vector rotates in the clockwise direction like this, the angle is measured as negative. So if here only, if you find out the angle below this line, so the angles measured like this, such an angle will be taken as a negative angle, and an angle which is measured above this. So suppose you measure this angle, so this angle would be considered as a positive. So the same thing applies here, whatever angle we obtain. So this would be a negative angle since it is going downward. This angle is measured in the downward direction. So this will be a negative angle. More specifically, this can be given to be a to be an angle or a negative angle. Okay. So I think now you can find out the distance and displacement over here. The displacement can be found out.
Yeah, sure.
Yes, sir.
So, in the terms of vectors, as we know that vectors are given magnitude as well as direction. So here we find out the magnitude which represents the length of the line, and the direction of the vector is represented by the angle. So this was about the displacement vector. In the similar way, we can find out about the velocity vector. The velocity is also a vector quantity, and it will also be represented as a vector. Okay, along with magnitude and direction. Okay, so any doubt in today's class?
I'm sure.
No doubt, sir.
Okay, so I hope you will be joining from the next class. Join on time. And Jaswant, were you not able to attempt the test?
So the maths and the chemistry, they were visible, sir, but the physics was not visible.
But I can see, Shreya, Shesi, what were you able to attempt it?
Yes, sir, I was able to.
Yeah, so you can check in the assessment section, it is available. Okay. So Shesi, yes,
Yeah, sir, I think he's confused because it was a assessment, sir, not a
yeah,
test.
it was an
That's it.
assessment.
So, but the other two tests came in like generally.
Okay. So again, check, it will be available and do it if you, I'll just check and if I can restart that test so that you will be doing it by email.
Okay,
Okay.
sir.
Bye all of you.
Okay, sir.
Yes, sir. Thank you, sir. Bye, sir.